Hello everyone, and welcome to the recursion interview problem number 3, the Fibonacci sequence. So in this interview exercise, we'll begin to get a feel of having to solve a single problem multiple ways. Alright, so if you decided to skip the memoization lecture reading material, you'll have to go back and read it in order to fully understand the various ways to solve this problem. So for this problem, what you're going to do is implement a Fibonacci sequence. In case you're unfamiliar with the Fibonacci sequence, you can go ahead and click the link that's provided for you in the notebook, and it'll take you to the Wikipedia page for the Fibonacci sequence. All it is just takes the last two numbers to define the next number of the sequence. So 1 plus 1 delivers 2, 1 plus 2 delivers 3, 2 plus 3 delivers 5, etc. Okay, so you can see how this is kind of set up already for you to do some sort of recursion in order to solve this problem. You can also use dynamic programming, which utilizes memoization. That will allow you to store results. Then you can also solve this problem iteratively. So let's just go over what the function is going to actually accept for input and what it'll output, and then we'll discuss each of the different methods of solving it. So your function is going to accept the number n, and then return the nth number of the Fibonacci sequence. So remember that a Fibonacci sequence, like I mentioned before, it's just a series of numbers, starts off of a base case, checks if it's either n equals 0 or 1. If that's the case, it would return 1. Otherwise, it returns something that looks like this sort of recursive sequence. So hopefully that's a big hint as far as solving it using basic recursion methods. So your first part of this interview problem will be solve the Fibonacci sequence problem. So for instance here, fill out this function using simple recursion to put in the n that you want, and it will put out the nth number of that sequence. So the 10th number in a Fibonacci sequence is 55. Okay, then you'll have to use dynamic programming, which will implement memoization using a cache to store results. You'll need to instantiate cache information. So I've put that here for you already, kind of as a setup, and then you can fill out that function. Again, you'll have to go back and do the homework reading material in order to fully understand memoization and go through that factorial example in both that notebook and the Wikipedia article reading from that lecture. After that, I want you to solve this iteratively, just using simple iteration. You'll have to use tuple unpacking, or you should use tuple unpacking. You don't have to, but it's definitely the better way to go as far as solving this. And here's an example of it being solved. So depending on which of these functions you want to test, you can test your solution with this cell. What you got to do is simply uncomment the one function you want to test. So for instance, right now, this will just test the first recursion function. Something I want to point out is, besides uncommenting, you'll have to take into account, especially for the dynamic programming, that you may need another input as far as the cache. I'll leave it at that so I don't kind of drop too many hints, but if you're having too much trouble with the normal recursion function taking just way too long, or having the dynamic version not pass any tests, go ahead and make sure that you can compare it to at least some of these first cases here and see if it sticks out the correct result. And then after that, go ahead and check out the solution notebook. So don't worry too much as far as this particular testing cell, because it may fail even if you have the right solution for some of these more complicated dynamic programming solutions. Or if you have a normal recursion solution, it may just take forever, and you shouldn't have to wait for that. You should just go and check your solution against the one in the solution notebook. All right. So again, this is good practice. A lot of times in an interview situation, you'll be asked to solve the same problem in multiple ways. So you can go ahead and do that here with the Fibonacci sequence problem. All right. I'll see you at the next lecture, where we're going to walk through the various solutions for this problem. All right. Thanks everyone, and best of luck.